Hello friends, welcome back to yet another interesting session on instrumentation and control in power plant industries. So let's start with our second session on getting ready for I&C interview. Our first question for the day is, what is the difference between wall positioner and an I to P converter? Friends, I stands for current and P stands for pressure. So I to P converter is basically current to pneumatic pressure converter. Friends, from DCS or PLC, we get 4 to 20 milliampere electric current command to operate our control valve. But to operate the piston physically, a physical pressure is required. So this I to P converter converts that 4 to 20 milliampere electric current signal into corresponding pneumatic pressure to open or close the control valve. Whereas a positioner, as the name indicates, is positioning the control valve between 0 to 100%. Means a positioner operates the control valve from 0 to 100%. These days, a combined electro-pneumatic positioner, basically smart positioner, is getting used in industries in which both I to P converter and positioner are integrated into a single unit. Friends, our next important question is, why is the equal percentage flow characteristics control valve more preferred in industry? Friends, based on the flow characteristics of control valve, we can segregate our control valve into basically three types. First one is linear opening control valve, second is equal percentage control valve, and the third one is quick opening control valve. Friends, as we know, a control valve is to be installed in a pipeline and a fluid will be flowing through the control valve. So this fluid flowing through the control valve could be linear flow or non-linear flow. So the choice is very simple. If the flow behavior is linear, then linear opening control valve is used. Whereas if the fluid behavior is non-linear, then equal percentage control valve is used. And in our power plants, in most cases, the fluid behavior is non-linear. Thus, equal percentage control valve is used instead of the linear opening control valve. Also, at lower opening position, say 0 to 20% opening, an equal percentage control valve provides precise control. Means at low opening percentage, the flow percentage will also be low, that is less flow. And as the opening percentage increases, the flow percentage also increases equally. And at 100% opening, it will act at its full capacity. Thus, it is preferred. Friends, next frequently asked question is, what is a control valve stroke test? Before understanding stroking test, let's understand what a stroke is. Stroke means full range of travel. Means if control valve is traveling from 0% to 100%, then its full range of travel is 0% to 100%. So, as the name suggests, stroking test is a test in which we check the opening of a control valve from 0% to 100%. Means the full stroke of control valve is tested in a stroking test. Simple. To do this stroking test, what we do is we give analog command from our DCS or PLC control system and check the corresponding actual opening of the control valve. Means from DCS we give 0%, then 25%, then 50%, then 75%, and then finally 100% opening command to the control valve and check the actual opening of the control valve in line with the given analog command. At 0% opening command, the control valve should be fully closed. At 25% opening command, the control valve should be exactly 25% open. Similarly, at other opening positions also the control valve is tested, and if the valve position feedback is not matching with the command, then definitely the control valve needs to be calibrated. Thus, control valve opening position is checked and ensured according to the opening command. Friends, this stroking test we generally do during our commissioning phase and during maintenance. This during our stroking test, our positioner is also tested that it is properly acting and positioning the control valve to the accurate position in line with the opening command received. Next, frequently asked question in I&C interviews: what is the role of cold junction compensation in a thermowell? Friends, a thermowell, we are aware of this. Sorry, thermocouple, we are aware is made up of two wires of dissimilar metals, and it consists of basically two dissimilar metals are joined at two junctions. One is hot junction, which is sensing the process fluid temperature, whereas the other end is cold junction. Due to the temperature difference between the hot junction and the cold junction, as per the Seebeck effect, an EMF is generated. EMF means basically a very small voltage in millivolts is produced. This hot junction basically is covered in thermowell and is in contact with the process fluid. So this hot junction measures the process fluid temperature, whereas the control this cold junction is also called reference junction, is in open environment, and the millivolts generated are basically directly proportional to the temperature difference between the hot junction and the cold junction. Clear? We have two dissimilar metals connected at two junctions. One junction is in contact of the process fluid and is not directly but through thermowell. This hot junction is measuring the process fluid temperature. Second junction is in open environment, and it if it is in open environment, then it is directly giving the ambient temperature. Then, due to this temperature difference between hot junction and cold junction, as per Seebeck effect, an EMF is produced, and this produced voltage is basically in millivolts, is directly proportional to the temperature difference between the hot junction and the cold junction. Friends, till now it is clear. Then ideally this cold junction should be at 0 degree Celsius. So the millivolt generated will be proportional to the hot junction temperature only. But we know our ambient temperature is not at 0 degree. Let's check with the, let's discuss this with an example. Maybe say the hot junction is at 300 degrees centigrade and the ambient temperature is at 25 degrees centigrade. Then the millivolt generated will be according to 300 minus this cold junction temperature, which is 25. So the millivolt generated will be proportional to 275 degrees centigrade. Then definitely this millivolt then will not be representing 300 is corresponding to 300 degrees centigrade. It will be reflecting according to 275 degrees centigrade. So which will provide a wrong reading. So it should ideally be according to the 300 degrees centigrade. Thus, a cold junction this cold junction compensation is necessary to eliminate the effect of ambient temperature on the cold junction. Answer is simple. This cold junction compensation is required to eliminate the effect of ambient temperature on the cold junction, because ideally cold junction temperature should be 0 degree centigrade, so that millivolt should directly be proportional to the hot junction temperature only. Then our next question is, and how we achieve this cold junction compensation? We basically, in our control system generally, we add back this our ambient temperature to the temperature difference between the hot junction and the cold junction. Next important question is, what is the difference? What is the benefit of digital signal in HART protocol when analog 4 to 20 milliampere is already available? Friends, in HART protocol, the analog signal transferred from the field instrument or transmitter to DCS or PLC is superimposed with a digital signal. Here in this diagram we can see analog signal is there, but a digital signal is also is superimposed on it. And this analog signal, which we are already aware, 4 to 20 milliampere signal, this signal is same, which gives us the measurement of the process parameter, whereas this additional digital signal, it basically carries additional information about the instrument settings, and these are transmitted to the DCS through this digital signal. This digital signal helps to calibrate the instrument from DCS itself. Means there is no need to go to the field and calibrate each and every instrument from the field. The means its instrument settings are transferred to the DCS cabinet through this digital signal. Thus, with the help of a handheld heart calibrator, engineer can calibrate these heart instruments from control room itself, instead of going to each and every instrument in the field. So, friends, in this session, we discussed some important I&C questions frequently asked in interviews. We will meet again in our next session with more such important interview questions. Till then, stay safe, stay healthy, take care. Bye.